Good morning, everyone. Today I'm discussing about toxic gas leak detection and other device using IoT and ML. In this, we are going to discuss about the introduction of our topic and purpose of the project, problem statement, proposed methodology, implementation, expected results and implications, conclusion, and references. Introduction goes on with harmful gas leak detection. And harmful gas leakage is serious unsafety that current gas detection systems are often expensive, complex, and require regular maintenance. This project aims to develop a low-cost, easy-to-deploy, and reliable system for detecting harmful gas leakage without connecting to any other devices. The system will use ESP8266 module, also known as Modem 0, and MQ quantitative gas sensor, and RFR, random forest regressor algorithm, to collect and analyze data from the gas sensor to detect harmful gas and send alert to people who are the surroundings. Our problem statement is in response to the imminent threat of toxic gas leaks. This project addresses the limitations of conventional detection methods by developing an advanced toxic gas leak detection and alert system. Leveraging IoT and ML, the system monitoring gases, concentration, temperature, and humidity using digital level sensor and MQ on the device engine. Through real-time analysis and alerts via SMS and email, the aim is to enhance early detection capabilities, ensuring prompt effectiveness responses to mitigate potential risks. Our purpose of the project is to prevent accidents. Like the main purpose of this project is to develop the system that detects harmful gas leaks early and inform people from the surroundings so that accidents can be prevented. And sensor integrations. These sensors are low-cost sensors. The system will use the sensors to detect harmful gases. Sensors are devices that can detect changes in the environment, such as temperature, pressure, and gas concentration. We used MQ135 sensor and humidity sensor. The cost effectiveness of this project is very low. This is important because it will make the system accessible to a wide range of people and organizations. The methodology of this project. Determining the data regarding the gas levels, those are above threshold values, and setting up the hardware requirements, connecting ESP8266 module with MQ135 gas sensor and DHT11 sensor, and also some connecting wires that can connect the sensors to the module within the breadboard, and programming the ESP module using Arduino IDE, which can collect data from sensor and send it to APIs like Blink. And through Blink, we can visualize the data, whatever label. And we can also, like, we use ML algorithm in PyCharm. And PyCharm will be using random forest algorithm to predict how toxic the gas is and alert the people by sending those information, those data to API, and from that API to mains and to followers. Pushing data to IoT platforms such as QuickManagement. Pushing the data from API to mains and followers can be done through automation tools like IFTT and Twilio. These tools are they trigger mails and messages to contact numbers. This can be used by implementing their libraries in PyCharm and Arduino IDE. The main source of this project is IoT platform. The platform which we used is Blink. It gets the data from the modem CU, which is ESP8266, and through pins to virtual pins. It reads the data from the module which is connected to the sensor, and it monitors the gas levels and humidity value or temperature value continuously. This non-MCU controller, it can be programmed in such a way that it can be linked through the IDs provided in with the implementation of this project. We will be starting with connecting the node MCU with THT11 sensor with pin configuration VCC pin to 5-volt pin and data pin to D node pin and node MCU and ground pin to ground pin. And the NQ135 sensor the same as THT11 sensor, but we use analog output pin to implement this project. um, After connecting the node MCU with the sensors, it will be integrated with C++ code through Arduino IDE. And in this code, we'll be having um, packages. Those can push the data which is read from sensors to Link, and there we can visualize the data. And we'll be setting a limit to the threshold values of gas sensors so that if it reaches the value, then the messages will be triggered in such a way that they'll be getting waves which will be showing in the output sensor. And then these values can be monitored through like continuously. The IDs which we used in this project are PyCharm and Arduino. PyCharm is for ML algorithm processing. In this, we integrated Twilio, which can propagate uh, messages to registered mobile number, and Arduino IDE is for reading the values from sensors through Node MCU, which can be configured by configuring pins, and the outputs are in Blink will be monitoring the God's values, temperature, humidity, and gas values, and through ML algorithm will be plotting graphs mm, of input values and like how the values are being read, and also the predicted toxic value and actual air value. And the final output will be the alert message sent to an email that it alerts gas is leak. And a message will also be sent to a mobile number which is being registered. The project successfully addresses the limitations of traditional gas leak detection methods by combining cutting-edge technologies. The seamless integration of IoT devices, machine learning algorithms, and cloud-based communication platforms contributes to a robust and responsive detection and alerting system. Flexibility of system allows for easy development and deployment in diverse environments, enhancing public safety and environmental quality. This is our conclusion, and we took references from different parts of the research papers, and these research papers helped us get the data about how to read sensor values and how to use IoT platforms and how to Arduino IDs. Thank you.